All right, so this problem says a car with a mass of 1,000 kg accelerates from 0 to 90 kilometers per hour in 10 seconds. We'll calculate its acceleration and the net force on the car. Yep. So the final velocity is 90 kilometers per hour. And we need to convert this speed to meters per second first. So this is 90. A kilometer, K is the prefix K is 10 to the power 3. So that is 10 to the power 3 meters. And 1 hour is 3,600 seconds. Okay. So essentially, to convert this to meters per second, all you do is divide by 3.6. All right, so the car accelerates from 0 to 25 meters per second in 10 seconds. Okay, so V equal to V naught plus AT. A is V minus V naught by T. So A, the acceleration is 2.5 meters per second square. G is 10 meters per second square, so you can see this is a quarter of that. So the thrust of the car, so to speak, is a quarter of the weight of the car. Okay, so it's a quarter mg. And then they ask you what is the net force on the car, and that's so the net force on the car, that is what gives it acceleration. Okay, so the mass times acceleration, and I'm going to not put numbers but write it like so. Acceleration is 2.5 meters per second square, and I'm going to write it in terms of g. You'll see in a second why I'm doing that. So what I've done, here's the mass of the car, there's the acceleration, and what is this guy? That is g divided by that is 1. Okay, that's unity. So I can multiply this by unity without, all I'm doing is stating the result in a different way. Okay, so this divided by that, see this divided by that, that's a dimensionless number. So you see this is a little more meaningful. The thrust of the engine, the net force that the engine is exerting is, this is the weight of the car. It's 25% the weight of the car. Okay. So if you wanted to buy a car where this number was, let's say, 0.5, the car would probably cost you 3 times as much. You want to go to 1, another 3 times as much. Okay. So that number costs you a lot of money. All right, so this problem says a rocket sled accelerates at a rate of 49 meters per second square. So you see this is 49 meters per second square, that is 5 Gs. So if you were sitting on this rocket, the force that was pushing you would be 5 times your body weight. you would stick to that seat. Okay, sled accelerates at a rate of 49 meters per second square. Its passenger has a mass of 75 kgs. Calculate the horizontal component of the force the seat exerts against his body. Compare this with his weight ratio. Okay. So here's the passenger sitting, and here is the seat exerting a force on him. And the seat is exerting a force equal to mass times his acceleration. And again, his acceleration was, and I'm going to write it like so. Okay, there's the force, and all I'm doing is multiplying it by unity. Okay. And so this is 5 mg. Okay, so the force that the seat exerts on him is 5 mg. Okay. And so you're pushing back on the seat with a force of 5 mg. All right. Calculate the direction and magnitude of the total force on him. So this is the force that the seat is exerting on him. Is there any other force acting on him? Gravity, the force of gravity, which is in that direction. Okay. So the total force on him will be in this direction. Okay. Calculate the direction and magnitude of the total force. So let's say if this is the x and y axis, the total force on him is 5 mgi minus mgj. Did you guys understand that? That's the horizontal force that the seat exerts on him, and minus mg in that direction, in the negative y direction. Okay. So that's the total force. They're asking you to find the magnitude of this force, which is okay. There's 25 plus 1, so root of 26 mg. Okay. So that's the magnitude of the force acting on him. And then we want to find the angle. Okay, we want to find this angle. And that angle theta is tan inverse of Fy over Fx. So tan inverse of minus 1 tan inverse of 1/5. Okay, so 11.3 degrees, minus 11.3 degrees. The negative sign tells you that the angle is measured clockwise. This problem says a fireman has a mass m. He hears the fire alarm and slides down the pole with an acceleration a, which is less than g in magnitude. Write an equation giving the vertical force he must apply to the pole. If if his mass is 90 kg and he has an acceleration of 5 meters per second, what is the magnitude of the applied force? All right. Okay, I mean, this kind of stuff happens for historical reason. Where do you think the first fire engines were? Fire stations were built? I'm sorry? So you build fire stations in big cities because one building goes on fire, then it'll destroy 20 other buildings. What's the problem in big cities? Real estate is expensive. Okay. So you build fire stations where you park the cars. You have small footprints. You park the car here, and then firemen have to be there all the time. So these are the living quarters. All right, a fire alarm goes off. You want to get there as fast as possible. You could jump down this building and get into your fire truck. Except that that's not good for your knees. Okay. So that's why the pole was invented. And then you slide down the pole. Okay. Well, gravity is pulling you down. So what you do is you grab onto the pole and apply friction. And now if this friction force is equal to your weight, you're not moving. I mean, you can, okay. So you apply appropriate friction so your acceleration is not too large. And your knees will last. That's the idea. All right, so we'll choose this direction as positive. mg minus F equal to, so this is the net force in the downward direction, and that's equal to your mass times acceleration. Okay. So F equal to mg minus A. Okay, bring this over here, that over there. So there is the magnitude of the force that you're applying. Okay, if the mass is 90 kg and if the acceleration is 5 meters per second squared. Okay, so the acceleration is 5 meters per second, that's half g essentially. That's half g, g minus half g is 1/2 g, so the force you're applying is half your body weight. Okay. And so now you see why they have to work out too all the time. They have to be strong. Their upper body has to be strong to save their knees. Okay. All right. Okay, so you saw what I'm doing. I'm converting this into G's. All right, so the magnitude of the force they're applying is half their body weight. So a truck collides with a car, and you guys all intuitively know what would you rather be in the car or the truck? The car. The truck, yep. All right, so why? What's that? No, Newton tells you otherwise. If this guy applies a force F on him, this guy applies an equal and opposite force on him.
accelerate less with the same.
Very good, very good. So our friend here has got it right. Force is mass times acceleration, okay? And the greater the mass of the truck, smaller its acceleration. Large accelerations are what cause damage, okay? So if you have to suffer large acceleration, something has to apply large forces on you, and that'll cause damage, okay? So that's why you want to be in a truck. The truck experiences a smaller acceleration because of its greater mass. All right. And all right, so suppose the mass of the car is 550 kg and the mass of the truck is 22,200 kgs, and the magnitude of the truck's acceleration is that. Find the magnitude of the car's acceleration. Okay, so mass of the truck. So we know from Newton's third law, the force on the car is the same as the force on the truck. Mass of the truck times acceleration of the truck should equal mass of the car times acceleration of the car. Okay. I'm just going to answer the question that we said. I'm not going to solve this problem. The acceleration you experience if you're in the truck is mass of the car divided by mass of the truck times acceleration of the car. So acceleration of the truck is, mass of the car is 550 kgs, 2200 kg. Okay, so if you're in a vehicle that's 4 times as heavy, your acceleration that you suffer is 1/4 as great. Okay. All right, if your vehicle is stuck in mud, what do? You attach a chain on it and pull on it. Okay, so let me show you. We'll see a better technique. Okay. Now, this is not always possible to do. So let's say your vehicle is stuck here. What you want to do is take a stiff cable and tie it to a tree or something like that, some immovable object. And then if you want to get it out here, what you want to do is push here. It's counterintuitive. And the reason you push here, and you'll see in a second, is if you push here, that will result in a tension here. And this tension can be 3 to 4 times this push. So this is acting like a simple machine. It's magnifying your force. Okay? So, all right, so the driver attempts to get that car out of the mud by exerting a perpendicular force of 610 newtons. 610 newtons, by the way, is roughly your weight. Okay? 60 kgs times 10 m times g. G is 9.8 meters, 10 meters per second squared. That's roughly your weight. And the distance she pushes in the middle of the rope is 1 meter. So there is the 1 meter. All right, again, we'll come to that in a second. So is 1 meter, while she stands 6 meters away from the car on the left and 6 meters from the right. Okay. What is the tension in the rope, and how do you find that answer? Okay. So what we'll do is so we'll look at this point. Okay, this point, and there are 3 forces acting on this link, so to speak. If you want to talk about, think of that link. There's a force F that you're pushing. The tension in this rope is acting in this direction, and the tension in this chain is acting in that direction. So that link is at rest. And so Mr. Newton tells us that these three forces, these have the same magnitude. Those three forces must add up to 0 because that link is at rest. Okay. All right. Well, so there's this angle theta, and let's find that theta. So how do we find that theta? That theta is, okay, this is 1 meter. Okay, this is 1 meter, and that is 6 meters. So 6 meters. So tan theta is 1/6, and theta is equal to 9.46 degrees. All right, so now, so you can see that the x component of this tension is canceling that. The y component of the two tensions add up to this force F. Okay, so 2t sine theta minus F equal to 0. Okay. So t equal to F over 2t. I mean, okay. So let me calculate this. F is 2 sine 9.46. All right, so here's why you did this. You could have attached this string and pulled on it. The force you would have applied was F. By doing this and pushing with that same force F, now the tension is 3 times as great. So this is a force multiplier. It's like a crowbar. So the mechanical advantage of this thing is 3. Okay. The input force was F. The output force was 3 times F. Okay. What is the price you paid?
Time?
I'm sorry?
Time?
No, you have plenty of time.
Distance?
Distance. You pushed 1 meter, and this thing will come out 1/3 a meter, which is it. But that's fine if it's in a ditch and it comes out, then you can drive it off. Yep.
I'm just going to ask, is it like common knowledge in physics that is a simple machine of choice? Or is there perhaps
I'm sorry?
is that like a textbook, so to speak, example or application of simple machines where all that really is a simple machine of choice to use? There's no other like quick trick that you
No, I mean, it's not common knowledge. This is the first time you heard. In fact, I was at a physics teachers conference over the summer. They showed us this demonstration. Not many people in the room knew about it. A college degree is sometimes useful. All right, so what force must be applied to a 100 kg crate on a frictionless plane inclined at 30 degrees to cause an acceleration of 2 meters per second square up the plane? Okay, so you're applying a force like that. Is there any other force act? So we're interested in motion along this line. The only other force acting on it is the component of the weight in this direction. And you guys know from your notes that component is mg sine theta, where theta is this angle. So the net force in that direction is F minus mg sine theta. And that's equal to mass times the acceleration of the car and of the crate. And this acceleration is given, that's the acceleration. So you can calculate the force. So the force you need to apply is mg sine theta plus m times a. Okay, you had to apply this much to balance that force and this additional force to make it accelerate that much. Okay. Okay, you guys can solve that. Sine 30 plus a. Okay. So they tell you the velocity of a 3 kg object at 6 seconds and 8 seconds are that and that. If the object is moving at constant acceleration, what is the force acting on it? So the acceleration is constant. So its acceleration is equal to the average acceleration if the acceleration is constant. And the average acceleration is given by the change in velocity over the change in time. Okay? And this happened over 2 seconds. Okay. So this is I, and then plus 6j, and minus 4k. So divided by 2 meters per second squared. So the acceleration is 0.5 I plus 3j meters per second squared. So the force on the object is the mass times acceleration. Okay, the mass is 3 kgs, so 3 times that, okay, is 1.5 I plus 9j newtons. So this problem says two forces act on a 5 kg object that moves with an acceleration of 2 meters per second in the positive y direction. Okay, so the object is accelerating in that direction. If one of the forces acts in the positive x direction, so here's force 1 acting in this direction, and has a magnitude of 12 newtons, so this is equal to 12I plus 0j. What is the magnitude of the other force? Okay, so they tell you the acceleration, net acceleration is in that direction. So what direction must the other force act? So the other force must act in that direction. The x component of that force must cancel this force because you can't have an acceleration in the x direction, and the y component is giving you this acceleration. Okay? Did you guys understand that? All right, so F2 must act in this direction. So what you want is, so your acceleration vector is 0I plus 2j. That's your resultant acceleration, okay? And F1 plus F2 should equal mass times your acceleration, okay? So F2 is m times a minus F1. The vector F2 is m times a. What is the mass? 5 kgs. So 5 times a is 0I plus 2j minus F1 is 12I plus 0j. So F2 is 10j minus 12y. So as we had said, it needed to have a negative x component equal to that, an x component equal canceling this, and then there's the y component giving you that acceleration. Okay. All right, guys, so